Hi guys, welcome to my channel MateABC English, and today we're going to see a proof of the Pythagorean Theorem. So let's get started. The proof goes like this. This is an easy one. This is a square of length a plus b. So we have that L equals a plus b. And remembering the formula to have the area of the square, it is L squared. So it is a plus b squared. So we have that a plus b squared equals a squared plus 2a times b plus b squared. And in the other hand, we have that this is a square also of length c. But these are rectangle triangles of length a and b and c. So the area of this rectangle, it is a times b divided by 2, and this is the same, a times b divided by 2, and this is a times b divided by 2, and also this. So this is a square, and the area of the square equals c squared. So we have that the area of this square, given these triangles construction, it is the sum 4 times a times b divided by 2 plus c squared. So these are equivalent. This is equal to a plus b squared because it is the same area given the formula of the length a plus b and also this construction. So we have that 4 divided by 2 equals 2 plus c squared, and this guys equals this, so it is a squared plus 2ab plus b squared. So it cancels with each other because of the identity additive on the real numbers, and we have finally that c squared equals a squared plus b squared, as we want to prove. So this guys is an easy one to discover the Pythagorean theorem, but it is crucial to see the elements from Euclid because it is the proposition 28 or 47 because it is the final proposition of the Euclid's elements part 1 or the book 1. So it is essential because it is a construction on postulates and everything before we get to the Pythagorean theorem. So this is an easy one, and when we get to geometry, Euclidean geometry, we're going to see the elements. So I hope you guys subscribe to the channel MateABC English. Bye!